everyone, welcome to the HCIP OpenELDR certification course. Now we continue to learn about the OpenELDR storage management. We have learned about 3 types of volumes creation method, and now we have a basic understanding of volume creation. In this section, we will take you through the creation of the remaining 2 types, that is, dispersed volume and distributed dispersed volume. After the creation is complete, we will take you through operations such as adding breaks, deleting breaks, and testing disaster recovery. So now, let's learn together.
Now, let's create a dispersed volume. Dispersed volume are different from what we will learn earlier. Dispersed volume are striped. First, we type cluster volume create, and then type its name. Let's enter the GV-DSP. And the number of stripes we need to create, because the dispersed volume is to stripe the file. So we have a few disperses in this. And then it's followed by the few stripes. According to the textbook, we have 3, and then a few of them are used for protection, like redundancy. So here is redundancy. Note that it is redundant numbers of the breaks. There is several blocks, and one of them we use for redundancy. And then we enter the location node 1 and VDB5 break, and then node 2. And then node 3. And after confirm, we press enter. The creation is successful. And then we start the volume. Start and enter the name GV disperse DISP. Then let's look at the information. Here the GV DISP is the protection mode of 1 times 2 plus 1, and there is no replication volume. It is 2 plus 1 protection mode. 2 are used for service and 1 is used for redundancy. This is a dispersed volume. And after the dispersed volume are complete, we can create a mount point on a client 1 to complete the mounting. And the mounting address is GFS dispersed, and then we mount. After mounting is complete, let's look at the mounting status. At this time, the mounting is already carried to DISP and the space is 4 gigabit. In this case, we share 3 breaks. Each of them are 2 gigabit, but the actual space is 4 gigabit because there were 2 plus 1 redundancy mode, so the space is 4 gigabit. And next, we also create 5 files. Okay, after created, And then we check that the used space becomes to 335, and compared with 135, it's 200 space have been used. And after the 5 files are created, let's look at the corresponding file information. We switch to corresponding VDB5 brick. And after we go into the folder, we see that have 5 files. If we look at the size, we can see that it occupies 100 megabytes space at this time. But when we create the space, it occupied 200 megabytes space, and the main 100 megabyte space is only half of the space. And also, the same for node 2. The same half of the space, and also the same for node 3. So here we see that the capacity of each node is half of the total space. So it means that we have created successfully and it creates separately. Okay, so this is our fourth type of dispersed volume. And now let's create the last one, the distributed dispersed volume. And here the distributed dispersed volume are similar to distributed replicated volume. The only one difference is that replicated volumes are replicated first and then distributed, while distributed dispersed volumes are dispersed first and then distributed. So here we need to determine which volumes are dispersed, and then we can form the distributed. Okay, so now let's finish the configuration. Cluster volume create, and then named GV-DD, distributed dispersed. And then we notice that we need to use all 6 VDBs, and then 3 VDBs are our dispersed volumes, and then their subvolumes to form our distributed volumes. Therefore, the command is same as the previous command for creating dispersed volumes. We entered 3 redundancy and set it to 1. And then you must put the VDB in squeeze. Otherwise, it will be run. So it must follow the right break squeeze. Okay, I've entered 6 of them, and make sure you will enter the path and spelling correctly. All of them is EXP VDB6 break. And here I have the 1 letter run, so I'll modify it. Okay, once the creation is complete, let's check it, and then we can press enter. Now we've created. And after the creation is successful, let's check the cluster volume info again. And after the configuration is complete, it's also don't forget to start it. So after the startup is complete, we create a folder named DD on client 1. And then we mount the folder. So here the mounted volume is gv-dd, and the mounted point is mount gfsdd directory. Okay, after the mounting is complete, let's check it. And we see that it's already mounted. And then the space is like we choose 8 gigabit. It's similarly, let's create some files. Okay, we finished the first one, second one, third one, fourth one, and finally, fifth one. Okay, we will finish the 5 files creation. So when we were done, let's look at the size of it. And it's the same 200 megabyte. And then let's check the file on the other nodes. Look at the information in node 1. At this time, we find there are 3 files in node 1. And we look at the size of node 1. The total size of node 1 is 61 megabyte. And then we turn to node 2 and found out that the node 2 was the same. And then it's also the test 1, 3, and 4. And then node 3 is also test 1, 3, and 4. And finally, node 4. Node 4 is test 2 and 5. So we can prove that the distributed is complete and the creation of the dispersed volume is complete. Among them, 1, 2, 3. Node 1, 2, 3 is the same, 61 megabyte. And then check whether the size of node 4 is 40 megabyte. At this time, the total space of the node 4 is 200 megabyte, and the size of each node is 40 megabyte. And then there are 3 test files in total, therefore the total space is 120 megabyte. Since we have 1, 2, 3 node and we have 2 plus 1 dispersed volume, so each occupies half of the space, about 61 megabyte, and node 4 is exactly 18 megabyte. So we found that node 4 and 5 are the same. And finally, node 6, now we have the 4, 5, 6 are same, 1, 2, 3 are same. It means we are finished the created now. And after we were finished creating 5 volumes, let's introduce a few extra information. First of all, we were talking about how to create from 0 to 1. So now, how do I add to my existing volumes? First of all, let's look at the first distributed volume we created. We query gv-dis. we can see that there are two of them now, node 1 and node 2. And now I'm going to add another one. So let's take cluster volume, and then, because now we need to add a break to the volume. So select add break, and then you need to enter which volume you want to add, and also the node you want to add. So node 3, VDB1 break. Okay, I'm going to add this to this. And then we were done. Let's look at the information, and we will see that there are 3 breaks already. So in this way, a new addition is complete. And then let's look at the disk space. We find that the DIS has changed from 4 gigabit to 6 gigabit. So I'm gonna finish it. So at this point, we find that the space is getting larger. So can I use this space directly? And let's create it again. So now we create 3 smaller files. Here you can see we have 5 of these, and then we will create a few new ones. And the name is turned to add1.txt, and also we use BS is 1 megabyte and the count is 40. Okay, now we create 1, 2, 3. And after we create 3, let's check it now. Now we already have 3 ADD. And then let's check. We go to node 1 and 2 and 3 to see if there is some new distributed volume information. At this point, we can see that there is an ADD1 in break of node 1. And then we go to node 2. We can see that there are 2 and 3 in node 2. Sitting here, does it seem a little bit wrong? Because we are now the distributed volume. 1 and 2 already have 1, 2, 3. That proves that there are nothing on node 3. So here we find it's nothing in node 3. Therefore, notice that when we first add it, it cannot be directly used. We need to deploy and rebalance. That is, rebalance our layout before we using it. So let's write about this. Cluster volume and then rebalance. So now we see it has been successful. Then let's look at our related information. Node 3 directly. At this time, is there a test 4 in node 3? And then in node 2, also 2, 3, 2, 5. And then in node 1, and we find that is test 1, 3, and then 2, 5. It reassigned test 4 to node 3. So is there already a file using by node 3? We add a new break to volume. So since there is the add operation, naturally there also have delete operation. Now I'm going to remove node 1 out of my volume. Okay, so how do we remove it? Also, we use cluster volume. Not adding a new one, there is a break removed from this, so remove to remove the break, and then the name GVDIS, and which one you want to remove, and write it here. So here, node 1, VDB1 breaks, and then it's followed by start. It's asked you to confirm, so we enter yes. And now we will remove it. So after the remove is complete, let's look at our information. There is nothing in it now, means we will remove it from our volume. And after that, let's look at the file information in node 2. Here's something already added to node 2. And then node 3 is still the same file. So it means we will remove all the things in node 1 to node 2. Okay, this is one of our breaks delete operation. So just now we explained the addition and deletion of our breaks. And then we told you about the creation of our 5 types of volumes. And now let's talk about the deletion of our volumes. So if we want to delete it, first we need to look at how many volumes we have. Cluster volume info, and we're looking for the details. And then how many volumes do we have now? I can change info to list. So I can look up the list of these volumes. In this, we have created the test volumes earlier, so now I'm going to delete it. And first, let's look at the status of test volume. In this, we can see a basic volume information, which is normal. Okay, so after volume 1 works, and then one of these breaks is node 4 and 5, so now I'm going to delete it. Before we delete it, we need to stop the volume. Cluster, stop. And then add the name, test. And select yes, delete it. Cluster volume, delete, and then test the volume. After deletion is complete, query it again. At this time, we find that there are only 5 volumes. From 6 to 5, it means we will finish deleting the volume. So after deleting the volume, the last experiment we were going to do is disaster test. So let's talk about the disaster test, which is turn off my node 1 and then to see if the rest volumes works properly. So now after stopping the cluster, we check the status. And now we can see that it's inactive here. I've closed it. And then let's look at its pool. Cluster pool list. And we cannot find it now because it failed to connect. So we turn to node 2. And then check it. At this time, we find 1, 3, 4, 5, 6, and node 2 is myself. That is, I can see 6 nodes now, but node 1 is disconnected. And now let's look at another situation of the entire services and see what is displayed. Cluster volume list. And then we query the status of cluster volume list, select several of them. For example, GVDIS DIS. Here is no node 1 belongs to it, so let's turn to GUIDT. And here, there are no node 1. So everything that involves node 1 is disconnected. So we find out that all of the node 1's files disconnected. And then we check the mounting. We find the space is normal and mounting is normal. So there is no trouble in this case. And finally, to make sure, we will go into one of our folders to see if the information is still here. For example, into DD, we see that the file is still here. Therefore, it indicates that even if one node fails, we can ensure that the service is running properly.
Let's look at our learning result through 2 questions. Question 1. Assume the device cannot be directly used after being mounted to a client and requires formatting before reading and writing. In this case, which storage type is most likely? Block storage, file storage, object storage, or backup storage? And here we can see the first one, block storage. To using block storage, you need to format before you can use. So A is correct. And about B, in case of file storage, we are sharing the directory, and the corresponding files in the directory can be directly viewed. So option B is not correct. And then for object storage, it's a URL link, so it does not need to be formatted. And the final one, backup storage, is just a backup. So finally, the correct answer is A, block storage. And then question 2, a distributed replicated value of GlusterFS exists of at least 6 bricks, with every 3 bricks formatting a replication group. Files within the volume are sliced and distributed according to the replication groups. This is true or false? So here, obviously, a distributed replicated volume needs 4 bricks, and a distributed dispersed volume needs 6 bursts. So the answer of the second question is false.
This chapter describes the basic concepts of storage. Typical storage structures, including shared centralized storage, SAN, NAS, and distributed storage, GlusterFS, and difference between the block storage, file storage, and object storage. In addition, we have added a large number of lab demonstrations to this course. We hope that through the lab demonstration, you can better understand the knowledge of storage management. After the class, I hope you can review the knowledge about storage management frequently. That's all for this chapter. Thank you for watching.